Hello, everyone, and thank you to be here for this presentation about Kubernetes threat model. I know it's close to the end of the day, and thanks again for that. My name is Maxime Coquerel. I'm a principal cloud security architect at RBC. RBC is the Royal Bank of Canada. Additionally to that, I'm also a CNCF ambassador and a Microsoft MVP. If you're interested to know more about myself, you can check my LinkedIn profile or go directly to my blog. I try to post articles about Kubernetes security and cloud security. Quick disclaimer, very important. Any view or opinion expressed in this presentation are only my opinion and not necessarily represent the opinion of my employer, its ownership, management, or its employee. Now, I just want to take a few seconds to put everyone up to speed with a quick reminder about the Kubernetes security architecture. What is important to remember specifically when we speak about security, is we have two big pieces. The first piece is a control plane piece, where you can imagine that is like the brain of your Kubernetes cluster, where you have some very serious and very important key components, such as the API server, which will be used to do the interaction between the control plane and the data plane. And additionally to that, also the scheduler, the controller manager, and some key value components, such as etcd. This one is very important because all the configuration of the Kubernetes cluster will be stored in this etcd cluster, and also some sensitive information, such as Kubernetes secret. On the data plane, if you are not very familiar, that is, the compute, part where you have your different virtual machine, which will run, the different Kubernetes workload. What is also very important for us, specifically for this presentation, is a kubelet. A kubelet is also a key component which will do the interaction between the API server and the node. The container runtime, where your container will run. For people which are not familiar, container runtime, you have Docker, you have Containerd. That is only a few examples. And for the networking piece, we have the kube proxy. As you can imagine, Kubernetes and all the ecosystem around Kubernetes is something very complex. We have a lot of security challenge because, that touch several different topics, such as identity, networking, deployment, also, compliance. From my personal opinion, I extracted all this security challenge, from the OWASP Kubernetes Top 10 project. And for my opinion, the biggest challenge is how you manage Kubernetes identity, because this identity, live inside your cluster sometime, and they are also not always linked to your cloud provider. But now, if we step back, as regulated organization, we can't move to the cloud in 2 seconds like that. We need to have a cloud security framework in place. When we want to release a new pattern, a pattern for me, it's a combination of different cloud services. We will package together and we will deploy that. This framework helps us, to follow some strict guidelines. The first action we will do is we will perform what we call a security review. A security review, it's a technical review, of the cloud services, and the goal of that is to identify, which security control we need to create and which potential threat we can have, if the cloud services is used without a well-hardened configuration. Additionally to that, the next step, we have the threat model. That is the subject of this presentation. Cloud control validation. For a lot of regulated organizations, they have their own internal cloud security framework. Sometimes that is inspired by the Cloud Security Alliance matrix. And, they will perform assessment of the pattern when the pattern is deployed in non-production. Pen test, because it's still good to have an external opinion about that. And scorecard. The scorecard, that is an IT risk document, and that will be fed, by the output of the security review, the threat model, the cloud control, and the pen test. All these findings, will feed the scorecard. The goal of the scorecard is to define an IT risk posture, and this IT risk posture will be correlated, with the data classification of your application, and also, what is very important is to have an idea, about the risk appetite of the organization, and all of that will be presented in the last step, what I call the cloud governance board. A cloud governance board, when in a regulated organization, you have the application team, you have the chief architect, you have the platform engineering team, and the scorecard is presented, and they will take a decision or not, to move forward in production. But for this presentation, we will focus on the threat model piece. But now, that is a question, a lot of people ask me, and specifically because I'm in the cloud security team, a lot of developers ask me this question is, Max, why we are doing a threat model? Why a threat model still matter? Do threat model is something very, very important, because that helps you, to have a proactive approach, and be able, to have all the stakeholders around the same table. You have the development team, the platform engineering team, the cloud security team, and, that help us, to do like a mapping exercise, and I will present that in the next slide. But when we are doing threat modeling, it's also very important to know which threat actor can maybe target your application. As you can imagine, if you have a sensitive application with PII data, you are not exposed to the same risk of just a classic internal application, with public data. That is very important to take that in consideration, because you will not put the same effort and the same amount of security control to protect this application. It's still, a balance of risk management. But it's also important to keep in consideration, if you have an insecure, internal application, this application maybe can use to do a lateral movement to compromise an application with sensitive data. That could be a vector of attack. Now, if we jump on the Kubernetes attack surface, as mentioned before, as you can imagine, we have a number of attacks, specifically because Kubernetes is something very complex, and it's also very easy to do potential misconfiguration. As you can see, on this Kubernetes attack surface, what is very important for me to highlight is we are seeing some new attack, for example, with a malicious admission controller. That is something, right now challenging, to protect. Specifically, when you deploy, an admission controller from an open source project, maybe you have a supply chain attack and you are deploying that, and that can also maybe compromise, your cluster. I put some example of threat we have in Kubernetes. For example, in etcd, by default, if you are leveraging, an Azure Kubernetes cluster, etcd is encrypted at the cloud provider level, but not encrypted with a CMK. Right now, that is something possible. You can do that only since a few months. Same thing with the node. What is also very important to understand, if someone, is able to do like a container escape and have an access to your node, it can inject directly malicious module in the kernel, and from that is also a game over of all your cluster. Network isolation, specifically with pod, that is also something very interesting, because if you deploy a Kubernetes cluster from scratch, I don't know if you know, but you are like, you have all your pod connected, to a layer 2 network, without any network segmentation. But now, you can ask me the question, okay, that is good, you speak about the different potential threats, but how I can, apply that to my organization? And what I wanted to share with you is a methodology we can use, The first thing to do in this methodology is to do what we call an architecture analysis. That means take the time to understand, the architecture you want to deploy. Next step will be to map all the access control, all the identity, because there are some type of identity, maybe you don't want to have. For example, service account with key. Maybe that is something very critical, because if someone is able to have to know the key, it's very easy to use those apps, specifically, if you are not rotating the different key. Data security, that is also a challenge for a lot of organizations because sometimes they don't know where their data with PII information, for example, are stored, and that is important to do a data security exercise, to do like discovery, right now on the market you have solutions like DSPM. Logging and monitoring, that is a key, because if you don't have log, you don't know what's happened inside your Kubernetes cluster, the day you will have an issue or something you want to investigate, that will be very challenging. Compute and network security, as I mentioned, specifically on the network piece, or you apply a proper network segmentation inside your different Kubernetes cluster, and also how you harden the different Kubernetes node. As you can imagine, some managed Kubernetes solutions such as Azure Kubernetes services, you are not able to customize the node OS image. Security control, we will detail that. You will have security control inside the Kubernetes cluster and outside the Kubernetes cluster, regulatory and compliance, and threat and finally, only at the end, threat and risk. To do an architecture analysis, what I recommend to do is to start with an existing framework. In our case, we use, the Microsoft Fast Track for Azure Architecture Review. That will help you, to have a list of questions you can ask, to the application team and to the platform team, and also be consistent. That means, every time you will do a review, ask the same question. IAM, the identity part, same thing. Do a mapping, try to identify some key and critical components, such as service principal. I don't know if you know, but by default, for example, in Azure, with an Azure service principal, if you don't have an Entra P2, you are not able to apply conditional access policy. That means if someone knows your service principal ID and secret, the person is able to use that from an untrusted internet access and access directly to your infrastructure. And also, what I mentioned, what is very also challenging, is how you identify the different local service accounts you can have, inside your Kubernetes cluster. For that, the good recommendation is to move with solutions like workload identity federation. Data security, as I mentioned, I will recommend not to store persistent data inside your Kubernetes cluster, but store that in external database, like Azure SQL database. You have some security measures you can put in place, such as SQL database field level encryption, private endpoint, and also to have like network communication enforced with protocols such as TLS 1.2. Compute and network security, as I mentioned, what is also very important, and specifically when you work with a managed Kubernetes version, Kubernetes cluster offered by cloud provider. Sometimes when you want to deploy the cluster, you need to open, some access to your firewall. For example, in Azure, you have no choice to open, the access to the NTP server and to some additional registry. Right now, some provider offer some air gap cluster. That is the case of Microsoft, but only since last year. Logging and monitoring, same thing as mentioned before. If you don't have different logs and you are not storing the log and ingesting the log in your SIEM solution, the day you will have an issue, that could be very tricky. Security control, that is a key piece, specifically, in the Kubernetes world, because you will have security control at the cloud provider level. For example, in Azure, we will enforce Azure policy or AWS config, and you will have also security control inside the Kubernetes cluster, because you want to put an additional layer to not, for example, have container running as root or any pod running without any limit, because that can DDoS your cluster. That is a type of security control you need to have. And finally, only at the end, we are at the last step of the methodology, you will perform, the threat and risk review, because that means, when you are at this stage, you can assume you have a good understanding about the architecture, about the different components of the architecture, the different identity, and also the different potential security control you can put in place, and you can map to the different threat. And, the goal of this exercise, is to try to find gap and find weaknesses and be able, to put a strategic plan to resolve that, and put an effort where, the weaknesses are. But now, you will ask me the question, Max, okay, it's good to do this type of exercise, for a cloud security architect is time consuming, because you can spend 2 weeks, 3 weeks to do that. You will do that, for example, in January, but in February, your threat model will be out to date. Why? Because the infrastructure will continue to evolve, your infrastructure will drift. And, if you are a small team, you can do that for only 1 threat model per month or 2 threat model per month max, but you are not able to scale. And that's the issue, I wanted to resolve, and I will suggest a solution in the next slide. But now, if we step back, the solution I wanted to share with you, I wanted to have something, which is light, which can be, which can run on a MacBook of a cloud security architect, something simple. We want also something where we can inject, YAML or JSON, or also a way you can describe, your different architecture. We want to have a solution which can automatically do some threat enumeration based on the previous threat model you have already done and based on your different hardening guide, such as the CIS benchmark for Kubernetes or also the different security review you have done. And we want also to have a solution which is able to do risk scoring and prioritization. That is a key because, as you can imagine, in a cloud security team, we have a cloud security architect with different specialties and also different level of knowledge. That means sometimes, the threat model is not very deep dive, and sometimes an architect will focus, more to one aspect, for example, the identity piece versus the network security piece. And that can create this discrepancy. And you don't want to have that because you want to be very consistent, specifically in the risk scoring rating. And also, you want to have a solution which is able to provide some recommendation, because at the end, it's good to enumerate the threat, it's good to map, the proper security control to this threat, but it's better, to have mitigation to this threat, because at the end, what we want to do is to reduce the risk posture of our pattern. And for that, my solution, what I will suggest to you today is to leverage an SLM. For people which are not familiar with SLM, an SLM, it's a small language model with a RAG solution. You can ask me why I don't choose an LLM solution, because in this case, what is very important for me is to have a portable solution, and also, I want to have a small language model which is trained, to help me to automatically generate a first draft of my different threat model. The first step in this case is to build what we call a knowledge base. So knowledge base, that will be, all your different documents that can be, the different CIS benchmarks, the previous threat model you have done in your organization, and also different hardening guide you have. It's very important to have a large knowledge base to have results which will be very oriented to with the content of your organization. The next step, when we have the knowledge base, is how we will expose that to a cloud security architect. We want to have something very easy to use, and in my case, what I suggest in this case is to leverage a solution called Open Web UI. You will see some screenshot after that. All of that, behind the scene, we will have a vector database. For this solution, I leverage Chroma, but if you want to scale with a large solution, I will suggest to shift from Chroma to PostgreSQL, for example. It's very easy to do that. After that, we will chunk the different documents, and we will have the SLM. And the small language model, in my case, I choose FIFO. It's a small language model created by Microsoft. Why it's interesting in this case is because this small language model focuses on the reasoning part, And to execute this small language model for this solution, I leverage Olama, but you have other solutions available on the market, such as VLLM, for example. And of course, in the web UI, you want to expose the answer, the response. Small language model, as you can see, that is a market which moves very, very fast. We have different solutions available right now. In my case, I choose FIFO, because as I mentioned before, what is very important for me is to have, a small language model which can focus on the reasoning part. That is my model called Kubernetes Threat Model Builder. That is based on my model FIFO. And what is also something very key is to define a system prompt. That means when you ask a question to your model, the system prompt will help you, to format the answer. And in the system prompt, what is very important to define is the role and the mission. For example, in my case, my system prompt, I said, you will be a senior cloud security architect specialized in Kubernetes threat modeling. And after that, I will define some goals, you need to do some scope and some assumption, in our case, we will focus, on EKS, AKS, and GKE and on-prem solution, some taxonomy and scoring. That is also very, very important because, for example, in this case, I will choose, the threat methodology I want for this example is Stride. Yeah, that is just to put you what is it. The knowledge base, as I mentioned, you will be able, to attach a knowledge base. What is also very strategic, is to have a very large knowledge base, with all your documents. That is some example, as you can see, in my knowledge base, I have some CN's benchmarks, some blog posts, also some previous threat model, for that we are very lucky because if you check on the GitHub of the CNCF, you will see some existing threat model, and you can ingest this threat model in your knowledge base. And when you will do your own threat model, some information came from of this document. And now, also, what is another key point is a prompt. That is your cloud security architect. You can ask me why I don't just upload an architecture diagram and say generate the threat model from an architecture diagram. I can do that. In this case, I need to use a multimodal model to do that. But sometimes you don't have all the information on the diagram, specifically, the information related about the identity. Sometimes it's also high level, not sometimes up to date, And, the prompt, that is something I believe, all the new cloud security architects, all the cloud security architects on the market should learn now how to prompt correctly. And, as you can see, that is some example, sorry, in my previous slide, I asked, to generate a threat model for Azure Kubernetes services, where workloads are exposed to internet with an Azure application gateway, I put all the information, the secrets are stored in an Azure Key Vault. We are also leveraging a CSI secret store driver. We are using a managed identity and all. And that is some example of results, if you remember correctly, in my system prompt, what I ask in the first thing is to do like some architecture and trust boundary, to identify different level of trust boundary, map, list all the IAM identity for me, and start to map all the different risks I can have, and you will see in this example, and all these risks are mapped to Stride, to some also MITRE ATT&CK, and we will do and the model will do the scoring. After that, you have technical details, with all the different findings. And you can see, on this screen capture, what is very interesting is you have also the source of the document, which is used to do that. And, because, do threat model in Confluence page or in Markdown documents, that is not something very scalable, You can also ask, and what I did in this case, I asked to my model, to generate that, directly in a JSON format, and that is also more understandable and reusable, by the other cloud security architect, and you can store that directly in a GitHub repository. And as you can see here, you have the different source used to generate this threat model. Just to conclude this presentation, what is very, very important in this case, the technological part is good, is great. It's possible to do that, as I mentioned and show to you today. But for my opinion, the key piece is a collaboration. That means if you don't have all the stakeholders around the same table, that means the application team, the platform team, the security team, to start to understand, all the architecture design, all that works, that will be not a success. I put some example of resource, some example of threat model you can use. I also, the system prompt I use. I also open sourced that. You can find the system prompt on my GitHub. And if you have any idea to move forward with this solution or any feedback, do not hesitate to reach me. If we can move forward together, that will be perfect for me. Thank you very much for your presence today. And if you have any question, I'm here. Thank you. And don't forget to rate the session. Yeah.
Can I ask a question?
Yeah, sure. Ask a question.
Do you have any data on how the efficacy of this model with respect to when you were doing it manually?
Right now, this model, that was only an experimental solution, I use that to help me to generate a lot of, to generate few threat model, I have, as you can imagine, we have some hallucination. That's the reason why I believe, in this case, that is more an assistant to help you, to generate the first draft of your threat model and help you to save a lot of time, Specifically, in the methodology I expose today, as you can imagine, we have 8 different steps, and, to map all the identity and understand the architecture, that is time consuming. And if you can use this solution to automate that, my goal with that is to reduce, my 2 or 3 weeks to generate a threat model to 1 or 2 days,
Maybe one more?
Yeah, sure. Go ahead. Ask all the questions you want.
Thank you. So as the Kubernetes version changes, the threat, I would imagine, will also change?
Yeah.
Is that correct?
Yeah, that is true. What is also very important, what you can ingest, is to have, an up-to-date knowledge base, because I mentioned, you can use existing threat model, existing security review, in large organization and in the large regulated organization, we are keeping the security review up to date, and, in this case, every time, we will do a change, in the security review. You can regenerate a new threat model. When you have this existing first draft of threat model, that will be very easy just to re-ask the solution to regenerate a new version and an up-to-date version.
Thank you.
You're welcome. Oh. I believe someone has also another question. Yeah, if you want to take the mic, yeah, because the talk will be recorded, yeah? Yeah, thank you.
So I got a question about the internal documentation part. If you have a different documentation, belong to different department and have a different confidential level, and how can you prevent the user of your model to access different information there?
Yeah, that is a very good question. And for that, in Open Web UI, and that's the reason why I use Open Web UI, is we are able, to create different knowledge base and different airbag group, and you can assign, the airbag group directly to this different knowledge base, And in this case, the model, will have access only to the knowledge base you will attach. And something I forgot to mention in this case, and what was also an hard requirement specifically for regulated organization, is when you want to generate a threat model, you don't want to call an external API such as OpenAI or Anthropic with Claude, for example. You want to keep that inside your organization. And in this case, the threat model we generate with this solution, we are fully offline.
Okay.
Thank you. Thank you for your question.
So from what I understand, you're using just an LLM to consume documents and then generate the threat model off of that. Is that correct?
It's correct. And
Okay.
what I'm currently doing in addition of that is not just a basic LLM. What is very important for me is in my system prompt, to be very specific about what I want to have in terms of output, But the next step, as you can imagine, we can have some next step with that. We can leverage MCP solution and agent solution. That is only the first iteration. But on my mind, I have already a roadmap defined for that.
Yeah, that's where I was going.
Yeah.
That was going to be the second part of my question. So whether you actually tried that or
No,
considering doing that next.
right now, no. But with solution like N8N, we can create orchestration workflow, and in this case, that will be very easy to do that. And specifically, because in my methodology, if we want to update. Right now, if you want to update a security review, to have up-to-date information, that is also very time-consuming, and that is a type of use case we can easily automate with a solution like N8N, because every time we have a change, for example, in the Azure Kubernetes documentation, we can extract this change, merge this change in the security review, and re-trigger a new threat model.
Thank you.
You're welcome. Any other question? If not, thank you very much, and have a good night.